So the first thing I'm going to have you do as you're flipping to today's notes is I want you to kind of look back at what we did yesterday. And the phrase we did yesterday, I said our sort of phrase I need you to walk out the door with is that idea of combining like radicals. In other words, you could add or subtract radicals when they have the exact same radical part. Okay, so these are the types of problems that we did in class yesterday. And then here is what we are doing today. So I have a question for you. What's the difference? Do you see it, John? Yeah, there's variables in these. Okay, so the way we write our answer when we simplify radical expressions that have variables in them, a little bit different. And I'll walk you through that today. All right, so we're going to do these 4 together, and then you're going to do those 2 on your own. And then hopefully that gets us to the point where we can actually get a little bit of a jump start on our book work for tonight. So that's where I'm heading with all this. We are simplifying radicals today. We are combining like radicals, and then this time there are variables underneath the radical. In other words, variables in our radicand. So in example 2, it says perform the indicated operations, and we're allowed to assume all variables are positive. So in part A, I have 2 square roots of 5x plus 2x times the square root of 5x. What I like about this problem so far is that, oh my gosh, it's such a nice segue from yesterday. Do you see we have the square root of 5x here and then the square root of 5x here? You're like, oh my gosh, they're like radicals. That's awesome. So we can attempt to, since those pieces are the same, combine them. But a little hiccup. Do you see the hiccup? Do you see the problem? Do you see it, John? Yeah, there's 2 and 2x. I'd love to put them together, but the coefficients don't match. So here's what John sees, in case you couldn't hear him. He sees that there's a 2 in front of the one root 5x, and then a 2x in front of the other root 5x. That's a little bit annoying because those aren't like terms. Those aren't like. So our book actually gives us another sort of way to write an equivalent expression for this one. What you'll notice is that they do have the square root of 5x in common. Hence, it is a common factor in both terms. So you can actually take this square root of 5x and factor it out of the problem using our GCF method. So you could ask yourself, well, if you take the square root of 5x out, what's left over for our first term? Well, the square root of 5x times 2 actually gets me back to 2 times the square root of 5x. And then to repeat this sort of distributive property backwards idea that we use in the GCF method, we ask ourselves the square root of 5x times what gets us back to 2x times the square root of 5x. And that's just 2x. So if I lop off the 5x's, or the square root of 5x's, I should say, we have 2 plus 2x left over. So this is how your book then will justify or rewrite an equivalent expression. And then even what John says even becomes more clear. Like you folks know, walking in the door, September, whatever day we started, it's the school year, I can't even remember. August, huh? You guys started in August. You see that there's a 2 and a 2x. Those aren't like terms. You can't combine them. This is done. It's just rewritten in a different way. We did this yesterday, too. I only made you do it one time yesterday, though, just to show you I'm not full of baloney. We did this yesterday. I swear we did. I'll show you. See? Right there. We said yesterday that, you know, we had 3 square roots of 2 plus 2 square roots of 2. You could actually just take that square root of 2 out of the problem, and then what was left over was 3 plus 2. This was another way to simplify our radical expressions yesterday when there were just numbers in the problem. Well, we do this strategy more often when there's letters, so that's why it's kind of coming up again today. We're working with letters. So I just wanted to show you that. All right, let's do it again. Part B, you look at it, you're like, oh man, the radicals aren't the same. This is in your note packet. Do you see where we're at? Did you lose a page? Yeah, you are missing a page. That is really random. I'm so sorry. How'd you lose a page in the middle of your note packet? Let's get you a new note packet, Ben. I'm sorry. That's like a mean April Fool's joke or something. No, you don't have to apologize. I don't know what happened. It's not your fault, that's for sure. Okay. So yeah, for some reason you're missing that page. You could even just tear it out and then merge it into whatever you're missing there. Okay. Working out. There you go. I'll save this for when somebody else will miss it on a different page. Okay, sorry about that. So in general, you know, we exercise this two-step process for simplifying or combining radicals. Right now, as it stands, you can't combine these, right? You can't combine these because they're not like terms. I need to get them to be like terms. So right now, I'm just going to simplify. I'm going to take some time right now to simplify the square root of 12x cubed. To simplify the square root of 12x cubed, you break it apart into its number piece and its letter piece. So I'm going to break this apart into the square root of 12 times the square root of x cubed. Anybody remember what that property is called? The property I just used to break that radical apart around its product is called the product property. Yes, very good. Okay. Moving forward then, I can simplify the square root of 12, right? That breaks down to 4 and 3. Square root each piece, you get 2 root 3. And then you have to ask yourself, well, hey, how many times does 2 go into 3? To simplify the variable part, 2 goes into 3 just one time. And then there is, oops, made a big 1 there, didn't mean to. 2 goes into 3 one time, and there is 1 x left over underneath. So that's x root x. When we kind of simplify or piece that simplified radical back together, what we get for that first term is 2x, because 2 and x were both outside of our radical there. And then what's underneath the radical is 3 and x. So it would be square root of 3x. Now I have to simplify the other radical. So I'm going to simplify the square root of 27 and the square root of x. 27 breaks down to 9 and 3. Square root each of those factors. The square root of 9 is 3, root 3. Bring down your square root of x. You can't simplify that. So what I'm going to do here is subtract. Well, because it said to subtract. So I bring across my minus, and then I'll write down my simplified square root of 27x. What's outside the radical stays outside. What's underneath stays underneath. And then do you see what I have there? I have like radical parts. I have like terms. So what I'm making you look at right now is this has now the square root of 3x, and this has the square root of 3x. Unfortunately, we're in a very similar situation as we were in part A. I have that 2x and that 3 that are outside, and they don't combine. So we just kind of write our answer in a factored form. We're going to pull that square root of 3x out of the problem. And what's left over is essentially 2x minus 3. So if I pulled out that 3x, do you see how there was a 2x and a minus 3 left over? That's what was in my parentheses there. So we simplify, and then we try to combine, but if we can't combine, we just write it in factored form. Questions so far? C and D, just a little more of the same. So part C, I am going to go ahead and simplify first. I'm going to simplify 4 square roots of 2x to the 5th. And then I'm going to simplify the square root of 50x. And then I'll try to find the difference between those simplified parts. So if I simplify 4 times the square root of 2x, I'm looking at 4 times the square root of 2 times the square root of x to the 5th. Sorry, I think that was it. I said x before. 4 doesn't simplify. The square root of 2 doesn't simplify. But the square root of x to the 5th does. And you just ask yourself, how many times does 2 go into 5? 2 goes into 5 twice. And then there is 1 left over. So anything that's outside the radical goes outside. Anything that's underneath stays underneath. So that's that first term, sort of, simplified a little bit. And now I'm going to simplify the square root of 50x. I did bring down my minus sign there. I don't know if you saw me do that. Brought down my minus. Now I'm going to simplify the square root of 50x. So I got to break it into its number part and its letter part. Square root of 50, that breaks down to 25 times 2. So as we look at that there, that's 5 root 2. Square root of x doesn't simplify. So when I write that term there, it's going to be 5 times the square root of 2x. And that does make me kind of happy because what I see is that they do have now that like radical part. They both have the square root of 2x hanging out on them. So I can actually write that down as a greatest common factor. They both have square root of 2x in common. And then after that, we have 4x squared minus 5 left over. We can't combine 4x squared and negative 5. Those aren't like terms, so those just hang out. Part D, for that problem there, we have 3 times the cube root of 6x minus the cube root of 48x. Again, I'm going to simplify each piece first. I could try to simplify 3, the cube root of 6, and the cube root of x, but none of those things simplify, so this guy's actually already done. That's kind of nice. A little bit of a break there. I would bring down my minus, and then I have to simplify the cube root of 48x. Careful, because this is a cube root problem. You should not be thinking right now, what perfect square goes into 48? You got to think what perfect cube goes into 48. So switch number sets in your head. John. It would be 8. Nice job. 8 times 6, right? Cube root each piece. Cube root of 8 is 2. Cube root of 6. And then the cube root of x doesn't simplify. So now my problem looks like, bring down my 3 cube roots of 6x there, minus, and then pretty this guy up a bit, you're looking at 2 cube roots of 6x. Oh, check it out. They do have that cube root of 6x on the end. Do you see that? And then, look at the front numbers, 3 minus 2. Those are like terms. You could use our factoring approach to take the cube root of 6x out if you wanted to. You're just going to have 3 minus 2 left in the parentheses, which is actually something that totally simplifies. 3 minus 2, you guys know what that is. That's 1. So you could multiply this by 1 if you wanted to. The big kids are just going to write their final answer as the cube root of 6x for that problem. So do you see how the parentheses simplified there? So I had to go a little bit further. What's up, Rick? $27 times 2 is 54. It's all right. Okay, so look carefully. Basically, we're doing the same 2 steps we did yesterday. We're going to break our radicals apart, simplify them first, and then you're going to try to combine like radicals. That's the phrase of the day from yesterday. Okay, so you have 2 to try on your own. If these 2 go well, then we're going to let you get started on your book work for tonight. I need to start, like I said, I passed back your tests, but I didn't get to check off your homework yet. So we're going to go ahead. I'm going to start doing that now. So I think, just one second. I'm sorry. You wanted to see your answers to your independent practice. Here they are. Number 1 was like a little curveball, I thought, after I went ahead and worked it out for you guys. You'll see that you have 4 root 5x minus 5x root 3x. There are 2 reasons why we could go no further. Can anybody give me one? John. Yeah, those roots, square root of 5x, square root of 3x, you can't simplify them. And what else? They are not, oh, what were we saying, Rick? Yeah, they're not like at all. So that's it. Done. With regard to number 2, bless you, you simplify each of the radicals in the problem, and you see that they do get a like radical part. So you can take that square root of x out, and what's left over is 6x squared plus 9. So that takes us to the end of our study on combining like radicals. That is what we did in this section. Eddie. You could, since you asked, take out a 3, but I'm looking for you to take the like radical out. So. Not at all. Like that. Also good. Yes.